All right, guys, we have to walk through the second example problem in the kinematics lessons. This one's a little tougher. It's a multi-step process. So pay attention. This is a good problem to work through. I like to have the three kinematics equations stuck up on the side here. Just no matter what we're doing, I like to put them up there. So here we go. We'll have our kinematics equations here. Maybe. Can I write them? Vf equals Vi plus At. Change in position equals VIT plus 1/2 AT squared. And VF squared equals VI squared plus 2A, change in position, 2AD. Keeping those things handy. All right. The process to solve these problems is very similar to the process of solving dynamics problems. You start with drawing a picture. So you draw a picture. Here's a car. This we'll call position 0. This we'll call time 0. And the car starts from rest. So VI equals 0. The car is going to go a long way. And at some point, it's going to get to here. When the car gets here, the position is, we don't know what the position is. We know it took 4 seconds. This change in time is 4 seconds, and it gets to a speed, 4 seconds later, it gets to a speed of 20 meters per second. We do not know what the car's acceleration during that part was or what the distance it traveled there. Then the car continues for a bit. The car continues for 100 more meters. We don't know how long it takes, but we do know that it continues at a constant speed. So it was at 20. This speed is still going to be 20 meters per second. It was moving at a constant rate. Oh, it was moving at a constant rate. It wasn't speeding up. It wasn't slowing down. They didn't mention anything about turning. So in this stretch here, the acceleration is 0. And then finally, the car comes over here. And what happens here? The driver hits the brakes. And the driver brings the car to a stop in 2 seconds. Whatever time here to here is 2-second interval. And the car comes to a stop. So the speed here is 0. Very important that you recognize that the car gets to a stop. So the acceleration, we don't know what it is 100%, really, but your answer for the acceleration is going to be negative because the car slows down. That means negative acceleration. Don't know what the value of the acceleration is, but it's going to be negative. There's your picture. There's everything you've got so far. Right? Car, distance, time, velocity. Car, distance, time, velocity. Distance, time, velocity. Distance, time, velocity. This is the process. This is the picture. Now it's just arithmetic. You draw the right picture. Everything else is simple. We need to know acceleration and we need to know distance. I always try this first equation first. It's the simplest one. What do we know? Vf equals Vi plus At. Do we know Vi? Do we know Vf? Yes, we do. Vf is 20 meters per second. Vi is 0 meters per second. Plus, we don't know acceleration, but we do know time. That time interval was 4 seconds. So you get 20 meters per second equals acceleration times 4 seconds. Divide by 4 seconds, divide by 4 seconds. Acceleration equals 5 meters per second per second. Now we know that. 5 meters per second per second. That's useful. Now let's see, can we figure out distance? Sure, we have two distance equations. Let's start with this first one. Change in distance equals VIT plus 1/2 AT squared. We want to know distance. VI was 0 times time, which was 4 seconds, plus 1/2. Acceleration we now figured out was 5 meters per second squared times time squared was 4 seconds squared. Do the arithmetic. 0 plus, 4 squared is 16. 16 times 5 is 80. 80 times 1/2 is 40. If you follow through the units, this becomes seconds squared. These second squareds will cancel out that second squared. You can end up with 40 meters. And that is absolutely what we should get. You're getting the change in distance to be 40 meters. So this change in this, I didn't write the change in distance here, 40 meters. This is going to tell me over here the total distance to that point really is 140 meters from where he started. All right. We know it's not accelerating here. What do we got going on here? So we've got dTV, dTV, no, we need T. We need an equation with time. VF equals VI plus AT. Well, this is going to not be the right equation to use here. If you do this math, you get, 20 meters per second equals 20 meters per second plus 0 times time. That's useless. We need the other equation with time. The other equation with time is this one. Distance, or change in distance, equals VIT plus 1/2 AT squared. This is the change in distance is 100 meters. The initial velocity is 20 meters per second. We want to know the time plus 1/2. The acceleration in that segment was 0 times time squared. That is so nice, because that means anything times 0 vanishes. That whole part of the equation is going to vanish. So you get 100 meters equals 20 meters per second times time. What times 20 gives you 100? You're going to get time equals 5 seconds. That's pretty useful. So now we know the change in time here was another 5 seconds, or the total time to that point was 0 to here was 4 seconds. 4 seconds plus another 5 seconds. Time total is now 9 seconds. That's our total time to there. From here, it's going to be another 2 seconds. So the time total, one of the questions, 11 seconds. We figured out that part, but we didn't figure out everything. dTV, we got all those. dTV, we don't have distance. We don't have acceleration. We have to do a little more math. We have to do a little more math to come up with the end of the problem. Give ourselves some more space. Okay, we know initial velocity, we know final velocity. The equation to always start with, VF equals VI plus AT. VF comes to rest 0. VI, it started at 20 meters per second plus A, and this whole thing took 2 seconds. Bring this over there. Minus 20 meters per second equals A times 2 seconds. Divide by 2 seconds, divide by 2 seconds. We're going to get negative 10 meters per second, or per second squared, equals A. Hey, that makes all the sense in the world, because we knew we were supposed to get a negative value here. It agrees. Awesome. So now we know the acceleration is negative 10 meters per second squared. And we can figure out the distance then. Now we can use pretty much either distance equation. We have two equations with distance in them. Vf squared equals Vi squared plus 2AD. Vf squared is 0. Vi squared is 20 meters per second squared. Whoa, what happened there? 20 meters per second squared. Plus 2 times the acceleration here is minus 10 meters per second squared times our change in distance. And we do this arithmetic, we'll get 400 meters squared per second squared plus minus 20 meters per second squared. All this equals 0. Times our change position. So here, minus 400 meters squared per second squared equals minus 20 meters per second squared times change in position. Divide both sides by minus 20 meters per second squared. Divide that whole side by minus 20 meters per second squared. Zeros, 40 divided by 2. 20 meters equals the change in position. 20 meters is the change in position. 20 meters. It was, right? 40 meters. 40 meters plus 100 meters, 140. 140 plus another 20. Distance total, 160 meters. Okay. So we were asked to find the total time and the total distance. Everything's there. Total time, 11 seconds. Total distance, 160 meters. That's the process. Draw the picture. DTV, DTV, DTV along the way. Multi-step problem.